4a in Algebra 2, talking about some imaginary numbers. What we've been doing so far is doing a lot of quadratic stuff, and quadratics, you should know, when you graph them, they form a parabola every time. We've been solving by factoring and doing all that stuff, and every time we solve a quadratic equation, we get the x-intercepts of that parabola. There's a parabola. Where's it across the x-axis at? Here's the x-axis, by the way. Where's this parabola across the x-axis? It doesn't, right? So does the graph have any x-intercepts, yes or no? No. Would the equation have any roots or solutions if y equals 0? Remember, if we tried to solve this by factoring or by quadratic formula or by complete the square, we'd want to find the roots or the solutions. Like if y equals 0, we put 0 in for y, and we try to solve that. Let's see if this can factor real quick. A value is 1, right? Is it a perfect square trinomial? He's a perfect square. He's a perfect square, right? So x, 2.
Teachers, will you please?
So, is the middle guy twice the product of those square roots, though? No, so that's not a perfect square trinomial. Can you find two numbers that multiply together to be 4 and add together to be 2? Numbers that multiply together to be 4, 1 and 4, 2 and 2, right? No dice, right? Can't factor it. If we did the quadratic formula, we'd get a negative number underneath the square root symbol. You know when you do the quadratic formula. And you know you can't take the square root of a negative number in the real number system. And you should be pretty familiar with what real numbers are. You know how we put in those double bar R's and saying from negative infinity to positive infinity. Real numbers are what you've been using your whole life. Well, they had a problem when they couldn't find the roots to this. So the answer, would this have any roots to this? Yes or no? No. Is it factorable? And no. There's no real solutions to this, but there are imaginary solutions. So that's what happened, is back in the day, when they were making up the rules for algebra and all that stuff, they said, hey man, like, we totally don't know how to do something like this, the square root of negative 1. Right? I can't think of two numbers the same that multiply together to be negative 1. So they said, all right, let's just make something up for it, just like they did with everything else. Like, let's just make something up for it. So they said, we're going to call that I, which stands for the imaginary numbers. This is the basic imaginary number. The square root of negative 1 is basically saying we're going to call that I right there. Cool? So then, if you took I times I, isn't that really saying you got the square root of negative 1 times the square root of negative 1, correct? And what's the square root of it times the square root? Isn't it the same thing saying you got square root of negative 1 squared in that situation? What does the square and the square root do to each other? So I times I, which is really I squared, equals negative 1. Those are some facts we're going to have to memorize for today. That the square root of negative 1 equals I, and that I squared equals negative 1. And I could explain it to you again and again and again. I'm just going to have to tell you, memorize it. It's like people are like, why is this true? They made it up. It's just one of those rules. It's like, why is the sky blue? Like, why did we call that sky the color blue? Because we made it up. Everyone agrees on it. Like, why didn't they call it hippopotamus instead of blue? Because everyone said, we're going to call it blue. Done, right? We agree. Cool. Why is the square root of negative 1 I? It's a made-up rule to help us. What do they use it for? Good question. You go into electrical engineering, you'll understand why you want to use imaginary numbers. I won't lie to you. I don't really get it either. You know, it's like I know what to do with it, but I never apply it to something in life. I'm not an electrical engineer, you know, of how to do with all the stuff that they deal with it. So it is useful in that field. I'm not familiar with electrical engineering. So we also got what's called pure imaginary numbers, like 6i, negative 2i, and I square roots of 3. They're called pure imaginary numbers because there's no real numbers involved with them, and we'll kind of see that as we go along here. So they want us to simplify these radicals. The square root of 64. That's going to be pretty simple because, square root of negative 64. That's going to be pretty simple because if you pretend it was positive, that's really all you have to do. Pretend it was positive. Or do this. Let's break this up into two radicals. And let's pull out a negative 1 right here and put a positive 64 in here. Remember when you'd simplify radicals, you'd split them up, and these are supposed to multiply together to be what's underneath there. Isn't negative 1 times 64 turn out to be negative 64? Well, 64 is a great number. So, what's the square root of negative 1, though, my friends? Do you know what the square root of negative 1 is? It's I. Do you know what the square root of 64 is? It's 8. Right? And we don't put plus or minus 8. You only put plus or minus when you solve stuff like this. If you had x squared equals 64, you would square root both sides and say x could equal 8 or negative 8. They're just asking you to square root 64, so you do the positive version of it only. Okay? So square root of negative 64, I split it up into the square root of negative 1, which we define to be I, and the square root of 64. Here's our answer. It's just not written in the proper form. You treat I just like a variable. If that was an x, would you write x8 or 8x? 8x. So this is 8I right here. The square root of negative 64 does not exist in the real number system. So we went into the imaginary world right here and said it's going to be 8I in that situation. Square root of negative 27 will not exist in the real number system. But we can go into imagination land and we can split them up into, we're going to do 3 radicals this time. We're going to see how smart we are. First of all, I'm definitely pulling out that square root of negative 1. And then the reason why I put 2 more radicals is because can the square root of positive 27 actually simplify? Like, what's the biggest perfect square that goes into 27 evenly? 9. And how many times does 9 go into 27? 3 times. So I just kind of split up into 3 situations. The negative part, then the square root of 27, I'm doing what we've been doing for a long time. So what's he turn into? What's the square root of negative 1? I. Square root of 9 is 3, and the square root of 3 cannot simplify, right? It's just the square root of 3. Cool? Then all we have to do is do a little bit of rearranging. We don't put I3, we put 3I square roots of 3 is what that will simplify to. Cool? Square root of negative 216. Well, definitely pulling out a square root of negative 1. Then let's see if the square root of 216, just all by himself, can simplify. I'll let you try to find the biggest perfect square that goes into 216 evenly. So, working backwards, we figured out that 36 goes in there 6 times. Is that correct? Right? So then we can kind of do 2 things at once. This is going to turn out to be what? What's the square root of negative 1 going to turn out to be? I. This is going to turn out to be 6. What order would you put it in? 6I square roots of 6, baby. 6I square roots of 6. Again, it doesn't exist in the real number system. You can't take the square root of a negative number, but they invented the imaginary number system. It's called complex numbers, which we'll learn here in a little bit, what they're called complex numbers. Please do this guy. Simplify the square root of negative 18. All you do is pull that square root of negative 1 out and then do the same old stuff like it was a square root of positive 18. Three I square roots of 2. Cool. 2 more. Find the biggest perfect square that goes into these evenly. On the left side, the biggest perfect square that goes into 72 evenly is 36. It goes in there twice. And you know you're pulling out the square root of negative 1. And as we get more and more comfortable with this, it's almost to the point where we won't even have to write this stuff down. At first, I think we should, but a lot of people are getting really good at simplifying radicals since it's the 3rd go-around in simplifying radicals. And if there's a negative underneath there, what's going to pop out of there every single time? What pops out when you take the square root of a negative number? The I, right? The I comes out. You're always taking out that square root of negative 1, so an I automatically pops out. But till I turn you loose to where I say you don't need to show work, keep kind of doing this for me. Okay, we'll get used to it. Now, they want us to multiply stuff together. Cool? It is a binomial times a binomial. Right? How do you multiply those together? FOIL. So let's FOIL this out. First terms times each other would be 4. Outside terms times each other, negative 2i. Inside terms times each other, positive 2i. And last terms times each other, what would I times negative I turn out to be? Should it be positive or negative? Negative. And then just treat it like a variable. If you know what x times x is, you know what I times I is. What's I times I? I squared, right? And it was negative. Y'all cool with that? Then we combine like terms. Ooh, check those out. What do those add up to be? Nothing. Or what do those add up to be? Nothing. How come I knew that beforehand, though? Why did I know that beforehand? What did you notice about those two binomials? They are conjugates of each other, which when you multiply them out, they turn out to be a difference of squares, but they are conjugates of each other. So these always add up to be nothing, but man, here's the thing. You're never allowed to have an answer with I to any other power than 1. You can't allow any I squareds, you can't allow any I cubes, I fourths, I fifths, etc. You've always got to simplify it down. So we have to realize what I squared is. Let me explain it to you one more time since some people were gone. Isn't I equal to the square root of negative 1? Correct? And if you take I squared, wouldn't you take the square root of negative 1 and square it? Right? And what is I squared turn out to be? What's the square root of negative 1 squared? Doesn't the square and the square root cancel each other out? And this is really negative 1. I squared equals negative 1. So what you have is 4 minus negative 1. Right? What's minus a minus turn out to be? Plus. So isn't this really 4 plus 1, which is how much? Oh my goodness. We took this number, which had some i's with it. That means it was imaginary. And we took this number, which had some i's with it. We multiplied them together, and did we get any imaginary stuff back? How come? What were these two things called again? Starts with a C. Conjugate. Those are called complex conjugates because these are complex numbers. What a complex number is it's involved with, it's got some imaginary numbers. Isn't that an imaginary number right there? And it's got this in there. That's a real number. Isn't 2 a real number, right? It's part of the real number system that you know. If you have a sum or difference of a real number and an imaginary number, that's called a complex number. So, again, question for you, just out of curiosity's sake. The green thing, is that a real number or an imaginary number? Just the green thing. Does it have an I with it, or does it not have an I with it? Has an I with it. So is it real or imaginary? That's an imaginary number. What about this guy? Is he real or is he imaginary? He's imaginary. If I was to list some other things, is that real or is that imaginary? 7. That's a real number. Now if I'd write this, doesn't it have 2 different guys with it? One of them is imaginary, correct? And one of them is real. That's called a complex number. So if it's got both, notice that was a multiplication problem. That's just one term. That's one term. Let's multiply them together. You treat them just like you were doing with variables. Number times number, what's negative 3 times 4? Negative 12. What's I times I? I squared. Uh-oh, you're not allowed to have a final answer with anything but I to the first in it. Right? I to the second can simplify, and we'll learn when we come back from break that I to the third, I to the fourth, I to anything else can simplify. Right? So what is I squared really? I squared equals how much? Negative 1. So this is really negative 12 times negative 1, which is how much, baby? Positive 12. Y'all cool with that?
Teachers, will you now?
This guy, Negative 5i times 3i. Number times number. What would you get? Negative 15. Then I times I is I squared, right? I want you to put negative 15i squared. Then, what's I squared really equal? So that would be negative 15 times negative 1, which is plain old 15, right? Next. Here's something you can't do. A lot of people say, hey man, let's multiply these together first. Like if I gave you this, radical 2 times radical 8, I showed you on that video, you should multiply those together and get radical 16 first. Take the 2 times the 8 and get radical 16. Well, that works only in the real number system. You can't do that with imaginary situations. If there's negatives underneath there, you can't take radical 6, negative 6, and negative 15, multiply them together, get a positive, and then take the square root of that positive number. It doesn't work that way. So, go in old school. This guy, don't you always pull out the square root of negative 1, and you'd be left with the square root of 6, right? On this guy, I'm going to pull out the square root of negative 1 and pull out the square root of 15. Just splitting them up. Awesome? Then, these, we know. What are those? What's the square root of negative 1, baby? It's not 1. Is it 1? Is it negative 1? Is it I? Or is it I squared? The square root of negative 1, that takes a while, right, is I. It's the basic imaginary number that we have. So this is really I square root of 6 times, isn't this guy also I right here? I square root of 15. So far, so good. I would see if these radicals by themselves can simplify before I go any further. Can the square root of 6 simplify? Can the square root of 15 simplify? No. So it's time to multiply these together now. I take my i's times i's. What's I times I? I squared. And radical 6 times radical 15. Just punch in 6 times 15 real quick. Now that they're positive square roots, you can do that. 6 times 15 would be 60, and another 30, square root of 90. Is that correct? Cool. Then I need to see if I can simplify the square root of 90. Oh, bet you 9 goes into that, right? Don't you think 9 goes into 90? So, I squared, how much is I squared? How much is I squared? It's really negative 1 times 2 radicals, square root of 9 times square root of 10. Correct? What's the square root of 9? 3, and we got it times negative 1 right away, so that's negative 3 square roots of 10. Wow. Let's do that again. This guy on the left. I think of him as positive before I get going. It's like, hey man, I got the square root of negative 20. I'm just thinking of him as the square root of 20. Can that simplify? Can the square root of 20 simplify? What's the perfect square that goes into him? So I'm going to go ahead and still show all the baby steps, but I'm going to go ahead and just split him up right away. You always pull the negative 1 out. Then I pulled out the biggest perfect square that went into 20. And I'll do the same thing to the square root of negative 12. Notice I'm using different colors also. You might do that on OneNote to see the two different terms that you had. You know, I did all this in blue. Now I'm doing all this in green. What's the biggest perfect square that goes into 12? 4, 3 times, right? Now, let's do all kinds of simplifying. This turns out to be what again? I. Square root of 4 is 2. Square root of 5 is square root of 5. I should have done that blue, but that's all right. Then this guy, how much is he? I times this guy, which is 2, and times square root of 3. I want you to also notice that I put a multiplication dot in between all of those, right? Just to realize that they're multiplied together, because it's hard to see when you have a radical and then you have a number after a radical if that number is supposed to be under the radical or not. I went ahead and just put dots in between all of them. So far, so good. Then I look at these radicals. They still can't simplify. Duh. We just simplified up here, so that's cool. Let's multiply our i's together. What's I times I? I squared. Then I'm going to say, I'm done with you, right, because we're getting messy. I'm going to multiply my numbers together, 2 times 2, which is 4. All right, done with you, done with you. Radical 5 times radical 3 will be radical 15. Y'all with me so far? Then there's one more thing that can clean up. I squared. What's I squared? Negative 1. Negative 4 square roots of 15. Nice. Those of you that play around with your calculators realize that your calculators can do this for you. I could care less. If you don't have this work, you are not right. Okay? So if you can figure out how your calculator can give you these answers, all the more power to you. Right? But again, it's the work shown on this. Cool? Nice. Were we cool with that, or would you like a couple more examples before we move on to the next concept? Would you want to do another one of those? So, solve each equation with pure imaginary solutions. X squared plus 64 equals 0, right? First question for you, is it quadratic? Yes or no? The answer will be yes if the biggest exponent you see is a 2. Is that quadratic? Yes. Let's go through the factoring cheat sheet, right? Is it a GCF that I could take out of this puppy? No, no GCFs. How many terms are there? 2 terms. When you have done the GCF step and you're left with 2 terms, the only thing over there is a difference of squares. Is this a difference of squares? This is a perfect square, and this is a perfect square, but why is this not a difference of squares? Because it's an addition problem. That's a sum, right? It's not a difference of squares. Are we cool with that before we move on? So this can't factor, baby. It's like we can't do the 3-term stuff because it doesn't even have 3 terms. This can't factor. But what we can do is use the square root method. Let's get x squared all by himself on one side of the equal sign. What would you do to get x squared all by himself? Subtract 64 from both sides. And there's where the problem comes in. Before we knew about imaginary solutions, we'd have x squared equals a negative number. We'd say no real solutions to this. It has no real solutions, but it will have imaginary solutions because I can still do this. Ba-boom, ba-boom. Square root both sides. What's this turn out to be right here? X. Now you've got to get the plus or minus situation going because you're solving an equation. Before, we were not solving equations. I gave you a problem like square root of negative 64. Please simplify it. Right? That's just an expression. Please simplify it. This is an equation you are solving. So here's the shortcut. We can do this all day if you want to. Do you realize that this will come out imaginary? Yes or no? Why does it have to come out imaginary? That's a negative underneath the radical. So if you ignore the negative for 1 second, do you like the number 64 when you're trying to square root? He's a perfect square. Isn't the square root of 64 turn out to be plus or minus 8, right? All we have to do is throw the one little thing in here that's going to make him imaginary. What do I need? I need an I. Again, going old school, like we did at the beginning of the hour, it's really negative 1, square root of negative 1 times the square root of 64. Doesn't this turn out to be I, and that turns out to be 8, right? It's really 8I when we have the plus or minus because we solved that equation. Y'all cool with that? Yes? No? Maybe? Cool. And then we put them in a solution set. 8I, negative 8I. There were 2 answers. Question for you. It's okay if it's fuzzy because it's new. Is that a parabola? Yes or no when I graph him? Is it a quadratic equation? Yes, it will make a parabola. How many places does this parabola cross the x-axis? Are these real answers or imaginary answers? Imaginary. Did we get any real answers at all? So, since there were no real answers, how many places did it cross the x-axis at? It doesn't cross the x-axis, and I hope you realize that that can totally happen when you graph a parabola. It doesn't have to cross the x-axis. What do these answers mean? Your guess is as good as mine, right? It has something to do with solving a quadratic, and electrical engineering is the field that I am most familiar with where they use them, but honestly, it's just a process to get some answers to help them solve whatever kind of situation they're in. So we're just helping you in case someday you want to go into engineering, you have knowledge of what imaginary numbers are all about. Next guy. Is he quadratic? Yes or no? Yeah. There is a GCF you can take out. You don't need to take him out because they tell us in the instructions, solve and get imaginary answers. There's only x squareds in here. Our idea is to get x squared all by himself on one side of the equal sign, and the GCF will work his way out. So what would you do first? Subtract 100. Cool. And then here's where the GCF of 4 works itself out, because don't you just divide both sides by 4 in this situation? So x squared equals negative 25, correct? Do you realize right now you don't get any real answers? Because a square equaling a negative can't happen in the real number system. But you can still solve in the imaginary number system. Do you like the number 25? Yes or no? Yes. So since that's the square root of negative 25, think of him as positive. You would get plus or minus 5. But who do you have to attach because it was negative in that situation? The I. Cool. Solution set. Oops. One more time. If I graph this, would it be a parabola? Yes. How many places does it cross the x-axis at? No places, because there are no real solutions to this. Cool. Next guy. Let's get x squared all by himself. 5x squared equals negative 45, correct? Hopefully you saw that there's a GCF of 5 in both terms, but isn't that GCF going to work his way out because our next move is to divide both sides by 5, right? So x squared equals negative 9. There you can see no real solutions are going to happen, but you will get imaginary solutions. So we will square root both sides. What's the square root of negative 9? Plus or minus 3i. Since 9 is a perfect square, just pretend he was positive for a second, because it's really taking the square root of negative 1 times the square root of 9. Square root of negative 1 is I, square root of 9 is 3, and you still have to do the plus or minus thing. Cool. Another one. Get x squared all by himself. Divide both sides by negative 9, right? Then x squared equals negative 1. I would square root both sides. And x equals plus or minus 1i, which we just usually write as I. Cool. 1 is a perfect square. The square root of 1 is 1. The negative part gives you the I. Noise. Another one. Oh, my bad. We didn't do it. Is that, do we have more? Yeah. Yeah, I didn't. So what is it? Go ahead and try 16 while I write it down. So I hope you've at least gotten started on this. What would you do first? Subtract 7, and x squared equals negative 7. When x squared is all by himself and he equals a negative, no real solutions are going to happen. But we can still get imaginary solutions. We'd square root both sides. Ba-boom, ba-boom, right? The problem here is that 7 is not the kind of number we like him to be. 7 is not a perfect square. So I'll show you the long way for a second. Wouldn't we do this? You don't have to write this down, but you do need the plus or minus, right? Because we're solving. You don't have to write it down yet. Just watch. You'd split him up into two radicals. right? That's what we do. And what's the square root of negative 1 turn out to be? I. So you'd have x equals plus or minus I square root of 7. Can the square root of 7 simplify? Yes or no? No. So that's what you just straight go to, my friends. You still do that same old trick. You think of him as positive. You're like, all right, if that was the square root of 7, I would say, can that simplify at all? Can the square root of 7 simplify? No. But what do I need to attach with that answer? An I. You still square root, so here's our answer. You've got to put the I first, and since the square root of 7 is not nice, you just keep in the square root of 7. I'm sorry, you need plus or minus. Cool? What we did before was the number underneath there wasn't perfect square, like a 25, so we square rooted it, and we got 5. The number was a 64, and we square rooted it, and we got 8. Well, the number underneath here is a 7, so I square rooted him, and I got the square root of 7. Right? Okay? So let's do the last one here. Let's get x squared all by himself. Right? 2x squared equals negative 10. Again, that GCF is weaseling his way out. X squared equals negative 5. Right? That tells you that there's no real solutions. I do need to square root both sides. You can put those radicals if you want to. You don't have to. You'll have plus or minus. Is 5 a perfect square? No. Can the square root of 5 simplify, though? No. But the thing that needs to pop out of here is the square root of negative 1, which is really I, and then the square root of 5 comes last. Cool? And sorry, we should have been putting these in solution sets. I square roots of 5 and negative I square roots of 5. And you do that with those other ones. When you're on your homework, you put them in solution sets. Number 15, let me go back. So the solution set would be I or negative I. Cool? Good question. Right? So, you all down with that? Cool. One last concept. Again, here's what I've been talking about all day. This is all the real numbers that we studied, in the past, honestly, your whole life. Some of them were newer to you the past few years. We just added these today, imaginary numbers. It's a whole new set, so you don't have to write this down, but that's like 3i, I square root of 2, stuff like that. Those are imaginary numbers. So if you put them all together, maybe, the whole ball of wax is called complex numbers. Complex numbers is made up of two things, reals and imaginaries. And when you add or subtract them together, you get a complex number. And that's it. There's no more types of numbers in this world after this. So you see that these are complex numbers. 6 plus I is a complex number. Because it's not 6i, it's 6 plus I. 6 is a real number, I is an imaginary number. And the standard form for complex numbers is supposed to be a plus bi. Who is the real number in this situation? Tell me who to highlight. Is a the real number or is bi the real number? A is real, and this guy is the imaginary number, right? It goes real plus imaginary. What are they asking you to do with these two complex numbers? You got this green one, and you got this blue one. Are they asking you to add them, subtract them, multiply them, or divide them? Add them, right? That's it. You can only add like terms. So you add reals with reals and imaginaries with imaginaries. Real is 6, real is 4. Add them together. What you got? 10. Then imaginaries, you'll have I plus negative 5i, which is how much? Negative 4i. And that's in what we call standard complex form. Cool? Real plus imaginary. Noise? Let's do it again. But what are they asking me to do with these guys? Subtract. I'm not a real fan of subtracting. I personally do this. I distribute the negative through, and I change all their signs if you want to, or if you just rewrite it. Say, I'd rather add them together, and I distribute the negative through. So my real numbers are 8 and negative 6, right? That's how much? 2. And 3 and 2i, which is 5i. Cool? Just add them / subtracting them together. not a problem at all. Noise? 18, also subtracting. I'm going to distribute the negative through. I'm going to put plus 1 minus 2i right here and throw that as a plus. Right? I distributed the negative through. And then that would be 5 plus 4i, right? And then this guy finally, negative 1. And then, ooh, doggy. How many i's do you get? 0i. But here's the thing. Should you put it or should you not put it? The question was how the instructions were worded. If they say put it in complex form, then this is not a complex number. Like, tell me what kind of number that is. What kind of number is negative 1? That's a real number. If they want a complex number, you better put plus 0i. Right? Because a complex number is supposed to have a representative for the real portion and for the imaginary portion. So this is saying I've got a negative 1 real number and no imaginary numbers in this problem whatsoever. Cool? So your homework will ask that a lot. Put them as complex numbers. What do they want me to do with these guys now? Multiply. Question, are they conjugates of each other? Are those conjugates of each other? 2 plus I, 3 minus I. Conjugates? No. They have to be the exact same thing. This is a 2, that's a 3, not the exact same numbers. So we FOIL them out. First terms times each other, 6. Outside guys, minus 2i. Inside guys, plus 3i. Last terms, what's I times negative I? I times negative I? Negative I squared. The positive times the negative, which will be negative, and then the I times I is I squared. Y'all cool in the neighborhood? Awesome. Like terms? These are like terms, correct? And I also have a nasty number in here. You're not allowed to have an answer with i's in it to another power than 1. This can be simplified. What is I squared really? This is negative 1 in the box. You have minus a minus 1, correct? What do you really have right there? So I do this, plus 1. That number right there is really minus 1, which is plus 1, correct? So I lightly cross him out and put plus 1. I know we're getting a little bored with this, but this concept that we're doing here, very important for next week. Are you cool with why this is plus 1? Nice. So like terms, aren't these like terms now? How much is that? 7. Those are my real numbers, correct? Imaginary numbers, I have how many i's? Plus 1 I. Sweet. 21. Are those conjugates of each other? Nope. So we FOIL them out. Do you notice, though, that you still got reals and imaginaries out of that situation? 4 minus 8i minus 2i, and then what's negative 2i plus times negative 2i? Plus 4i squared. Right? Check this out. Our next move, once we start getting better at this, is to change him. Aren't there I squareds involved? How much is I squared? It's negative 1. You have 4 times negative 1. What does that turn out to be? So I lightly cross him out, and I put minus 4 right on top of him. I squared is negative 1. So you had 4 times negative 1. Now, let's add up all our stuff. Like term-wise, 4 and negative 4. How much? 0. Should we put him since they want complex numbers? You have to put him, right? That's our real number. There are 0 real numbers. Imaginary, negative 10i. Complex numbers have to have both pieces in them. A real number and an imaginary number. Sweet. 22. Get her done. Get her done. Pause the video. Check when you're done. I have FOILed him out. Everyone cool with my FOILing? My next move is to change him. Anywhere there's I squareds, I need to change him. I squared how much again? Sorry to beat a dead horse, but how much is I squared? Negative 1 times 2. Do you realize it changes that guy's sign is what all that happens, right? It's like the I squared goes away, and it changes the sign of whatever was in front of him. Now, real numbers, you have 18 minus 13i. Is that right? Cool. Last one, notice anything about those two numbers? Conjugates. Do you want to do it the long way, or do you want to do it the short way? What happens when you multiply conjugates together in the FOIL process? What happens every single time? The outside guys and the inside guys add up to be nothing. I'll give you a quick example with real numbers. What's the conjugate of 2x plus 3? 2x minus 3. Let me FOIL them out. 4x squared minus 6x. What's the other guy turn out to be? Plus 6x minus 9. What do those add up to be every time? Nothing, right? You don't need to do the FOIL process. All you have to do is take the first terms times each other. 3 times 3. How much? 9. Then you don't like square the terms or anything like that. It's first terms times each other. Then you take the last terms times each other. 2i times negative 2i is how much? 2i times negative 2i. Negative 4i squared. Correct? You all down with that? If we'd have done it the long way, you'd have had a minus 6i and then a plus 6i in there. They still add up to be nothing. Correct? Now, something still needs to simplify. What do I simplify? I squared is negative 1. So what does this guy turn out to really be? Plus 4. All right? It was a minus 4i squared. That's really positive 4. And then 9 plus 4 is 13. Did you notice all the imaginary stuff canceled out? Should I put it? Only reason you put it? Because they wanted a complex number. Nice? Let's do some OneNote.